Hi dear students, welcome to the next topic from waves, and last sessions we have seen about the standing wave, or it is also called stationary wave. So one important point which I have mentioned there, if you have not noted down, please note down that the standing waves will not carry any energy, okay, but the traveling wave or the plane progressive wave will carry energy, and we have learned the equation: kinetic energy, potential energy, and total energy, power, average power, intensity, etc. Okay, now today we are going to continue the application of standing wave. Where will be the standing waves are applied, or where the standing waves are available. So we are going to find out the standing waves which are producing on a string, in a normal string, and we'll find the velocity of the standing wave. Not the velocity, the frequency. Okay, of course we need velocity to find out the frequency of the standing wave. This is the topic of discussions today, and some few other topics related to this one: Newton's law and Laplace correction, and so on. So let's start with, so please write down the first heading related to this one: standing waves on a string fixed at both ends. Standing waves on a string fixed at both end. Standing waves on a string fixed at both end. രണ്ട് എൻഡോടെ ഫിക്സ് ചെയ്ത ഒരു സ്ട്രിങ്, അതിൽ ക്രിയേറ്റ് ചെയ്യുന്ന സ്റ്റാൻഡിങ് വേവ്സ്. ഓക്കെ, സോ ഒരു സ്ട്രിങ്, the string is fixed at both end. അപ്പോൾ ഇതിൽ മിനിമം ഫോം ആവണ ഒരു വേവ് ലെങ്ത് മീൻസ് ഇതിൽ ഫസ്റ്റിൽ ഫോം ആവണത്. സോ ദിസ് ഈസ് കാൾഡ്, ഫസ്റ്റ് ടൈം കാൾ ഇറ്റ് ആസ് ഫസ്റ്റ് ഹാർമോണിക്. ഫസ്റ്റ് ഹെഡിങ് ആണ് ഫസ്റ്റ് ഹാർമോണിക്, or this is also called fundamental frequency. First harmonic is also called fundamental frequency. First harmonic and fundamental frequency. ഇപ്പോൾ ലെറ്റ്സ് ഹാവ് ദിസ് സ്ട്രിങ്. ഇതേമാതിരി സ്ട്രിങ് എടുത്തനാൽ വിത്ത് ദ സ്ട്രിങ് ഈസ് ഫിക്സ്ഡ് അറ്റ് ബോത്ത് എൻഡ്സ്. അപ്പോൾ ഇതിൽ മിനിമം ഫോം ആവണ ഒരു സ്ട്രിങ്ങിൻ്റെ ഒരു റിപ്പിൾ മീൻസ് ദിസ് മച്ച്. ഈ ഒരു അപ്പം സ്റ്റാൻഡിങ് വേവ്സിൽ ഐ ടോൾ ഓൾ ദ വേവ്സ് വിൽ സ്റ്റാൻഡ് അപ്പ്, ഓൾ ദ വേവ്സ് വിൽ സിറ്റ് ഡൗൺ, ഓൾ ദ വേവ്സ് വിൽ ഗോ ഡൗൺ. അപ്പോൾ അത് റെപ്രസെൻ്റ് ചെയ്തിട്ടാണ് ഈ 3 ലൈൻസ് കാണിക്കുന്നത്. ഒന്ന് ഈ നോഡ്, അപ്പർ ആൻറ്റി നോഡ്, ലോവർ ആൻറ്റി നോഡ്സ്, and this one is the 0th position or the node position, and these edges are actually all the particles are coming to rest, and this is called a node. Now this is called the fundamental frequency. We are going to find out the fundamental frequency, but now here this is the minimum amount of the ripple. അത് ജസ്റ്റ് ഒരു റിപ്പിൾ ആണ് ഈ ഒരു സ്ട്രിങ്ങിൽ ഫോം ആവുന്ന മിനിമം കണ്ടീഷൻസ്. അപ്പോൾ ഈ ഒരു റിപ്പിൾ മീൻസ് ഈ സ്ട്രിങ്ങിൻ്റെ ലെങ്ത് എടുത്താൽ നൗ ഐ ക്യാൻ സേ ലെങ്ത് വിൽ ബി ഈക്വൽ ടു ലാംഡ ഡിവൈഡ് ബൈ 2. ഇത് എന്നുള്ളത് ഇപ്പോൾ കംപ്ലീറ്റ് ആയിട്ട് ഒരു ഫുൾ വേവ് ആണ് ലാംഡ എന്ന് പറയുന്നത്, കറക്റ്റ് തന്നെ. സോ ഹാഫ് ഓഫ് ദിസ് വൺ, ഇതാണ് ഒരു റിപ്പിൾ. സോ ഇറ്റ് ഈസ് ലാംഡ ബൈ 2. സോ ഫ്രം ദിസ് ഇക്വേഷൻ ഐ നോ ലാംഡ ഈക്വൽ ടു 2L. So this is clear. I know the equations for velocity. Velocity is what? Root of T by mu. T is the tension, mu is the mass per length. So T is called the tension on the string, and mu equal to mass per length. This already we have seen. Now we are going to find out the frequency. How will we find out the frequency? What is the expression for velocity? I know velocity will be equal to frequency into lambda. Frequency will be equal to velocity by lambda. What is velocity? I know velocity is root of T by mu. So root of T by mu. Lambda is how much? 2L. So lambda is how much? 2L. So it is 1 by 2L into root of T by mu. This is called F1. F1 means first harmonic nulla represent ആണ്. ഇല്ലനാ we can write this as F1 equal to FL. FL means fundamental frequency. Fundamental frequency represent the notation on FL. F1 means the first harmonic. So which is equal to 1 by 2L into root of T by mu. So ഈ ഒരു സ്ട്രിങ്ങിൽ ഫോം ആവണ മിനിമം ആയിട്ടുള്ള ഫസ്റ്റ് റിപ്പിൾ, ആ റിപ്പിൾ ക്രിയേറ്റ് ചെയ്യുന്ന ഫ്രീക്വൻസി, ദാറ്റ് ഫ്രീക്വൻസി ഇസ് കാൾഡ് ഫണ്ടമെൻ്റൽ ഫ്രീക്വൻസി, അല്ലെങ്കിൽ ഫസ്റ്റ് ഹാർമോണിക്. Okay, but first harmonic of a string f1 fl equal to 1 by 2l into root of t by mu. So the important now. So we are going to see the next part. So this is called the first harmonic, or this is also called fundamental frequency. Okay, and this will also have one more name, which is called fundamental mode. And all are same. Question paper different terms you can see. Fundamental mode. So fundamental mode if it is mentioned, fundamental frequency if it is mentioned, first harmonic it is mentioned, all these are the same thing. F1 equal to fl equal to 1 by 2l into root of t divided by mu. So let's go to the next one. So first harmonics ആണ് ഇതിന്റെ ഒരു ഫണ്ടമെന്റൽ ക്രൈറ്റീരിയ. So next first harmonics ഇടുന്ന what will be the second means the next possible combination. Next possible combination means fundamentals means it is a very basics one. From the basics one we can form the next one. Next one is called second harmonic. Second harmonics will have another name which is called first overtone. So second harmonics, or it is also called first overtone. So how the waves will be formed in that case in a string, it is like a two ripples. First ripple fundamental first harmonic, and this is called the second harmonic, and this is called first overtone. Easy, and harmonics second harmonic is called the first overtone. So what is the full length will be here? Each piece is lambda by 2. So this lambda by 2, idum lambda by 2. So total is lambda. So L will be equal to lambda. Okay. So now I know frequency will be equal to velocity divided by lambda. Velocity means lambda is L. So 1 by L into root of t by mu. This is called what? This is called second harmonic. So let's represent as F2. And F2 is called the second harmonic. Another name of the second harmonic is called first overtone. Okay, ഈ ടോൺ എന്നുള്ളത് യൂസ് ചെയ്യുന്നത് ഈ മ്യൂസിക്കൽ ഇൻസ്ട്രുമെൻറ്റിൽ യൂസ് ചെയ്യുന്നൊരു ടേമാണ്. ഓക്കെ, അപ്പോൾ ഒരു സ്ട്രിങ്ങിൽ ബേസിക് ആയിട്ട് ഫോം ചെയ്യാൻ പറ്റുന്ന ഒരു റിപ്പിളാണ് അതിൻ്റെ ഒരു മിനിമംസ് ഉണ്ട്. ആ മിനിമം വിട്ടുകഴിഞ്ഞാൽ പിന്നെ അടുത്ത ലെവൽസ് ഉണ്ട് രണ്ട് റിപ്പിൾസ്. അതുകൊണ്ടാണ് അതിൻ്റെ സെക്കൻഡ് ഹാർമോണിക്സ്, സെക്കൻഡ് ഹാർമണി. So let's go to the next one, third harmonics. So third harmonics, and this is also called what? The next one, second overtone. Second overtone. So third harmonics, strings are fixed on both ends. How many ripples will be formed? 1, 2, and then 3. So 3 ripples is possible. In straight line, if you want, you can draw, else it is also fine. So 3 ripples. So lambda by 2, lambda by 2, lambda by 2. So L equal to how many lambda by 2? 3 lambda by 2s are there. Okay. So lambda is equal to how much? 2L divided by 3. So frequency, third harmonic. So F3. F3 is equal to what? V by lambda. So V is what? Root of T by mu. By lambda. Lambda means what? 1 by 2L by 3. 2L by 3 is 3 numerator. So 3 by 2L. 3 by 12. This is called the third harmonics. The similar way, and so on. And so on means and so on. And so on means what? What is possible? Fourth harmonic, fourth harmonic, fifth harmonic, etc. It is possible, and so on. So all these harmonics will be are possible. Okay. So next we are going to write some additional notes on top of this one. Now we know the first harmonics, now we know the second harmonics, now we know the third harmonics, we know the first overtone, second overtone, fundamental frequency. All these names are depends on each other. So let's summarize this one. Let's write some couple of points. You can write on a note means some points. What are the frequency? F1 will be equal to 1 by 2L into root of T by mu, and F2 will be equal to 2 by, I can write this as 2 by 2L, right? 2 by 2L means 1 by L into root of T by mu. So F3 will be equal to 3 by 2L into root of T by mu. This is equal to 1 by L into root of T by mu, but I just written like this one. And so on, and so on. In this case, Okay, so what will be the nth harmonics? Nth harmonics means what will come will be here. N will be n divided by 2l into root of t by mu. So either you have to remember n is the harmonic number. Harmonic number ആണ് n will be equal to. Okay, so f2 ipo. Okay, next point. f2 will be equal to 2 times of f1. Similarly, f3 will be equal to how many times of f1? 3 times of f1. Similarly, if you go like this one, I can say fn equal to n times of f1. So fundamental frequency n which multiply that you will get the nth harmonic frequency. So fn equal to n into f1. It's correct, right? 6 ipa third harmonics 3 into f1. So 3 into f1 means 1 by 12 into root of t by mu. You will get f3. Okay, this is summary. So what are the harmonics in the ratio? For example, f1 is to f2 is to f3 is to etc. What is the ratio? 1 by 2l divided by t by mu. Idine x ennaduthana. For example, let me take this as x. You will complete factor I am considering as x. So how much this x? X is to 2x is to 3x is to and so on will come, right? Idine x aayittu eduthana. If I am taking this as x, then this is 2x, this is 3x, correct alle? You whole factor in x side edutana, what this will come as 3x. What this will come as 2x. That's what I have written. X is to 2x is to 3x is to, which is equal to 1 is to 2 is to 3 is to etc. So this is the ratio of the frequencies in a string. ഒരു സ്ട്രിങ്ങിലുള്ള frequency, first harmonics, starting from first harmonics till the nth harmonics, the ratio is 1 is to 2 is to 3 is to 4 is to etc. Which means what? All the integers, like from starting from 1, all the odd number, all the even numbers, everything will be present, which means all the harmonics are present in a string. Important ആണ്, all the harmonics are present on a string. Very important. Okay, fine. So let's go to the next topic, and which is called sound wave. Standing waves on a string, it's clear. Let's move to the next topic, and which is called sound wave. A questions to you: sound wave is a transverse wave or sound wave is a longitudinal wave? Sound wave is a transverse wave or sound wave is a longitudinal wave. What is called transverse wave? The vibration of the particle is perpendicular and wave is propagating in this direction. Both are making 90 degree to each other. That is called transverse wave. Longitudinal wave means what? Longitudinal means particles are vibrating like this back and forth, and wave is traveling in the forward direction, and this is called longitudinal waves. Now can you tell me, the sound wave is a longitudinal wave or sound wave is a transverse wave? Sound wave is a best example of a longitudinal wave. Because how the sound wave is propagating? Sound wave is propagating because of the compression and rare fractions in the air medium. Once you are speaking, your voice will go and compress some amount of air. So the other side, the air is relaxed. Then next again, this compression will propagate forward. This will compress the rare fractioned area, and the other area become rare fraction. Okay, so it's compression certain area, rare fraction, compression, rare fraction, compression, rare fraction. So this way the sound waves are progressing. So let's write some theoretical points over here, some conceptual points. Sound waves. Please write down the heading called sound waves. Adile number 1, sound waves are longitudinal waves. Okay, so sound waves create pressure difference in air, in terms of compression and rare fraction. Compression means pressure koodi area, that is called compression. In terms of compression and rare fraction. In terms of compression and rarefaction, which means let's assume if a sound wave is traveling will be here, ഈ സൈഡിൽ എയർ ഭയങ്കര കൺജസ്റ്റഡ് ആയിരിക്കും. ഇങ്ങനെ എയർ ഇങ്ങനെ റിലാക്സ് ചെയ്ത് തിരുപ്പി എഗെയിൻ എയർ ഇങ്ങനെ കംപ്രസ് ചെയ്ത് ഇങ്ങനെ ഡൗൺ ആയി എഗെയിൻ ഇങ്ങനെ കംപ്രസ് ചെയ്യും. എയർ ബിക്കം കംപ്രസ്ഡ് like this. So this point is actually called the compressed, more pressure ഉള്ള ഏരിയ ആയിരിക്കും എയർലി ഭാഗം, കംപ്രഷൻ ഏരിയ. ഈ ഒരു ഭാഗമാണ് ദിസ് ഇസ് കോൾഡ് റയർ ഫ്രാക്ഷൻ. ഇതേമാതിരിയാണ് സൗണ്ട് പ്രൊപ്പഗേറ്റ് ചെയ്യുന്നത്. അപ്പോൾ അതായത് എയറിൽ കൊടുക്കുന്ന പ്രഷർ ഡിഫറൻസ് ആണ് ഈ സൗണ്ട് വേവ് ഈസ് ഗെറ്റിംഗ് പ്രൊപ്പഗേറ്റിംഗ്. അത് ജസ്റ്റ് ബേസിക് ആയിട്ട് യു ഹാവ് ടു റിമെമ്പർ. അതാണ് അതിൻ്റെ ഒരു ഫണ്ടമെൻ്റൽ പ്രിൻസിപ്പിൾ. ഓക്കെ, ഇനി ലെറ്റ്സ് go and discuss some details about the sound wave. Okay. Some details about the sound waves we need to discuss. Okay, so this is an important concept within the waves chapter. Please write on the heading: speed of the longitudinal wave. Speed of the longitudinal wave means what? Sound wave. Speed of the longitudinal wave. Speed of the longitudinal wave. In bracket you can write it as sound waves. Okay. Sound wave. ഈ സൗണ്ട് വേവ്സിൻ്റെ ഒരു ജനറൽ എക്സ്പ്രഷൻ ഉണ്ട്. ഈ സൗണ്ട് വേവ്സിൻ്റെ സ്പീഡ് കണ്ടുപിടിക്കുന്നതിനുള്ള ജനറൽ എക്സ്പ്രഷനാണ് വെലോസിറ്റി ഈസ് ഈക്വൽ ടു റൂട്ട് ഓഫ് ബി ബൈ റോ എന്ന് എഴുതും. റൂട്ട് ഓഫ് ബി ബൈ റോ. I'll tell you what is. B is called, in properties of matter you have learned, this is called bulk modulus. And rho is called density. Bulk modulus. The bulk modulus general bulk modulus use ചെയ്യും. If this is the case, sound is propagating in liquid or gas. Liquid gas we are using the term called bulk modulus. Similarly, we will write V is equal to root of Y by rho. Y is called what? Young's modulus. Y is called the Young's modulus. Where we will use Young's modulus? This is for solids. സോളിഡ്സിലാണ് നമ്മളത് യൂസ് ചെയ്യുന്നത്. സോളിഡ്സ് വരുമ്പോൾ വൈ ബൈ റോ എന്ന് വരും. ഗ്യാസസ് ലിക്വിഡ്സ് വരുമ്പോൾ ദിസ് വിൽ ബിക്കംസ് ആസ് ബി ബൈ റോ. ഇറ്റ് വിൽ ബി ടേൺ ഇറ്റ് ആസ് ബി ബൈ റോ എന്ന് വരും. ഓക്കെ, ബി മീൻസ് ബൾക്ക് മോഡുലസ്. ചില ടെക്സ്റ്റ് ബുക്കിൽ അത് ബീറ്റ എന്ന് റെപ്രസെൻ്റ് ചെയ്യും, ബട്ട് ബി ബൈ റോ. സോ ഇൻ ജനറൽ, okay, so I'm writing additional point called in general. So this B and Y, it's called what? Coefficient of elasticity. So velocity is equal to root of E by rho എന്ന് എഴുതാം. E by rho. E is called coefficient of elasticity. അത് അതിൻ്റെ ജനറൽ നെയിമാണ്. ഈ കോയഫിഷ്യൻ്റ് ഓഫ് ഇലാസ്റ്റിസിറ്റി എന്ന് ചൊല്ലിനാൽ അത് ഗ്യാസസ് ഇല്ല ലിക്വിഡ്സ് വരുമ്പോൾ ഇറ്റ് ബിക്കം ബൾക്ക് മോഡുലസ്. അത് സോളിഡ്സ് ആകുമ്പോൾ ഇറ്റ് ബിക്കം യങ്സ് മോഡുലസ്. അപ്പം ഇ ഈസ് ഈക്വൽ ടു ബി ആവാം, ഇല്ലെന്ന വൈ ആവാം, ഡിപ്പെൻഡ്സ് അപ്പോൺ ദി മീഡിയം. ആ ഒരു കോൺസെപ്റ്റ് യു ഹാവ് ടു നോ. ഓക്കെ, ഫൈൻ. ഇനി ഈ സ്പീഡ് ഓഫ് സൗണ്ട് വേവ്സിൻ്റെ ഫസ്റ്റ് ഇതിൻ്റെ ഒരു കാൽക്കുലേഷൻസ്. ഓക്കെ, സ്പീഡ് ഓഫ് സൗണ്ട്, വാട്ട് ഈസ് എ നോർമൽ സ്പീഡ് ഓഫ് സൗണ്ട് വേവ് ഇൻ ആൻ എയർ മീഡിയം? അത് ഒരു 340 360 ആ ഒരു റേഞ്ചിലാണ്. അതായത് ഒരു 340 to 360 അതാണ് അതിൻ്റെ ഒരു അപ്രോക്സിമേറ്റ് റേഞ്ച് ഓഫ് സ്പീഡ്. നോർമലി നമ്മൾ സ്റ്റാൻഡേർഡായിട്ട് 340 നടക്കും. സോ അതാണ് സ്പീഡ് ഓഫ് ദി സൗണ്ട് വേവ് ഇൻ എ നോർമൽ എയർ മീഡിയം. ഇറ്റ് ഈസ് അപ്രോക്സിമേറ്റ്ലി 340 meter/second ആണ്. അതൊരു എക്സ്പെരിമെൻ്റലി പ്രൂവൺ തിങ് ആണ്. ബട്ട് അത് മാത്തമാറ്റിക്കലായിട്ടും ഓക്കെ, സയൻസിൽ ഇഫ് ആൻ ഇൻവെൻഷൻ ഈസ് ഹാപ്പനിങ് ഇൻ 2 ways we have to prove. One is experimentally we have to show. Experimentally means നമ്മൾ റിയൽ ലൈഫിൽ നടക്കുന്ന എക്സാമ്പിൾസ് ബേസ് ചെയ്തിട്ട് അതിലൊരു എക്സ്പെരിമെൻറ്റേഷൻ സെറ്റപ്പിൽ we have to prove the value. ഒരു അതർ കേസസിൽ ഇതിന് ലിറ്റിൽ ബിറ്റ് ഓർ ഒതൻറ്റിസിറ്റി വരണമെങ്കിൽ, ടു ഹാവ് ആൻ ഒതൻറ്റിസിറ്റി വി ഹാവ് ടു പ്രൂവ് ഇറ്റ് മാത്തമാറ്റിക്കലി ആൾസോ. അതായത് തിയറിറ്റിക്കലി കിടക്കുന്ന വാല്യൂവും പ്രാക്ടിക്കലി കിടക്കുന്ന വാല്യൂവും ഈക്വൽ ആയിരിക്കണം. So then only that hypothesis will be getting accepted by the world. So in that cases, the speed of the sound wave first to mathematical manipulations അല്ലെങ്കിൽ ഒരു mathematical equations first time it is introduced by Newton. In Newton ഈ ഒരു concept, okay, we can calculate the velocity of sound in air medium using this concept, and he proposed some postulates. We are going to see what he proposed, how we can calculate the speed of sound wave by using certain kind of formula which you have learned in the previous chapters. Okay, so let's see that. So we can write speed of the longitudinal wave or sound wave. Okay, sound wave, adana heading. Adil kuda oru partum kuda we have to add. Okay, based on Newton's law. So speed of the longitudinal wave or sound waves by Newton. Now we will see how Newton is proposed this law by Newton. So Newton told the sound waves are traveled in an air and it is an isothermal process. Isothermal process, I don't think it's a new term for you. Isothermal means what? Constant temperature. Okay, so what is Newton's postulate is that, so you can write down, Newton mentioned that sound waves traveled in air medium. In air medium, he told like that. Okay, sound waves can travel in a air medium, and the process is, means our event, the process is isothermal, and the process is isothermal. In physics, what is called isothermal? There is no temperature difference, delta T equal to 0, then it is called an isothermal. You have learned, right? Isothermal process, adiabatic process, like that. So delta T is equal to 0, which means there is no change in the temperature. So if there is no change in the process, for an isothermal process, next point on for an isothermal process, we have a very famous equation. Pressure into volume is constant. This is the conditions we are learning, right? Pressure into volume is constant. If pressure into volume is constant, then that equations can be applied in case of a isothermal process. Now I want to find out, I know the general equation of velocity. Velocity is equal to root of b by rho, because in air medium it is bulk modulus will come. So what I am going to do means, I am going to substitute, I am going to find out an equation for bulk modulus. So let's see. So for that I am differentiating this one. So let's do differentiation on both sides. രണ്ട് സൈഡിൽ equation differentiate ചെയ്യാം. Okay, രണ്ട് സൈഡിൽ equation differentiate ചെയ്യുമ്പോൾ what will get? P into dv plus v into dp, constant differentiations 0. Okay, now we know what is called bulk modulus. So as far as I know, the bulk modulus B is equal to, how will find out the expression for the bulk modulus? It's a pressure difference minus of dp divided by v divided by dv. So this is called the bulk modulus. I need to derive some expression like this from here. Okay, so let's take P is equal to minus V dP divided by dV. Okay, this can be written as P is equal to minus dP. Adinte adhe formula I can write this one, right? If V in a denominator lotu come, so dV, sorry, okay, dV divided by V. So pressure equal to minus dP and P into dV minus V dP dV. Okay, so I can write the equations of the pressure and the equations. How I can write as minus dP, let's say P into dV plus V into dP will be equal to 0, pressure, ഈ pressure എടുത്തന V dP minus ഈ സൈഡ് കൊടുക്കുന്നു minus V dP divided by dV. Okay, so pressure equal to minus dP dV divided by V. So how I can write the equation for that one? P is equal to, now I need to have an equation for this one, right? Okay, so how we can do this equations, how we can connect these equations with that one? Now we need to connect these equations with that one. So dP divided by dV by V. What is dV by dV by V? That is called the bulk modulus. Okay, here I have written it's incorrectly. It is dV by V. Please correct it. Sorry for that. dV divided by V. This is the expression for bulk modulus. Some textbook it's also using the expression, the letter for bulk modulus as equal to K. Appo the confused aagudadu. So K is some reference textbook like K enna bulk modulus at representative, chelappo B nu representative, beta nu representative, all are same. So what is this whole factor now? Now this P is equal to minus dP dV by V. This is equal to the bulk modulus P. Now I can write the equations for velocity. Velocity is equal to what I have written, B by rho nedi. So if B by rho means P by rho. Where the experiment is happening? This experiment is happening in an air medium. I know the pressure of the air medium. What is the pressure of the air medium? And standard value 1.05 into 10 power 5 on. So idum air on density of air on. Density of air is 1.29. If you simplify this one, what is the value will get? 10 raised to 5. It will be a little bit of less. So ഇതിന്റെ values പറയുന്നത് 280 meter per second ആണ്, approximately ആണ് 280 meter per second. This is the pressure of air and this is the density of air. അപ്പോൾ pressure of air with the density of air, we will get the value will be equal to 280 meter per second. അപ്പോൾ actually ഒരു speed of the sound wave in air medium normally the standard values are 340 meter per second ആണ്. അപ്പോൾ 340 meter per second നിന്ന് as per the Newton hypothesis, the value comes as 280 meter per second. So that is correct or wrong? That is, of course, it is a correct. So Newton postulate is wrong. Okay, so Newton postulate is wrong means the practical or the experimental value of the sound wave in air is 340 meter per second, but through the Newton postulates we got the value is equal to 280 meter per second, which means there is a difference of 60 meter per second. So this is against the value from the experimental result. So I am writing one more additional points over here. So the Newton's theory is a failure. So we'll write Newton's theory is a failure. Other failure ആയിരുന്നു because what? Theoretical means the value. Theoretical value of sound wave speed is approximately equal to 340 meter per second. Theoretical value of the sound wave, theoretical value means this one, sorry, 280 meter per second, 280 meter per second, but practically or experimentally, its value is 340 meter per second. So both are different, okay, but practically the value is equal to 340 meter per second. Hence the theory is wrong. The theory is an incorrect theory, so that we are getting a difference of 60 meter per second. Okay, this is wrong. So what we can do in these cases? Another scientist, and whose name is called Laplace, he came and he done some corrections to the Newton's theory and he makes some other postulates. So let's see what postulates he's made. So for Laplace, the trigger point is the Newton itself. Even though Newton's theory is failed also, Newton is giving a trigger to continue the experiment on the sound wave speed in air medium. Okay, now instead of sound wave, now the next heading, so the speed of the longitudinal wave or sound wave by Laplace correction. Laplace ആണ് സയൻറ്റിസ്റ്റിൻ്റെ പേര്. He made some correction to the equation. That's what it is called a Laplace correction. Laplace correction. What is Laplace correction? He told according to Laplace. So according to Laplace, we will write according to Laplace. According to Laplace. Laplace is a name of a scientist. Laplace transform എന്ന് പറഞ്ഞാൽ ഭയങ്കര പോപ്പുലറാണ്. So according to Laplace, the propagation of the sound wave, okay, the propagation of sound wave, the propagation of sound wave forms compression and rarefaction. Compression and rarefaction. So this is similar to what Newton is also told, but the process is not isothermal. He told the process is not isothermal. This isothermal process avilla. The process is not isothermal. The temperature increases at the compressed area. The temperature is increases at the compressed area. At the compressed area and decreases, correct logically think pannalum correct tha, and decreases at the rarefactioned area. So ee rarefactioned area il temperature it's less, but ee compressed area il temperature it's adhigam. So it is not an isothermal process. And next point, and this is an adiabatic process. This is an adiabatic process. So what is the equations for adiabatic? So this follow the equation. So this follow the equation. What is adiabatic in equation is what? Not PV is equal to constant. PV is equal to constant is isothermal process. PV raised to gamma is constant. PV raised to gamma is constant. Gamma is a parameter. What is gamma? Gamma is equal to Cp divided by Cv, right? You also learned. Gamma is equal to Cp divided by Cv. Illana idikku or expression is 1 plus 2 by f and sollu. Okay. ഈ 2 by f ആണ് നോർമലായിട്ട് വി ആർ യൂസിങ് 2 by f. ഇതിൽ f is called it's a parameter. Okay, f is called freedom of degree illana degree of freedom. We can say degree of freedom. Okay, degree of freedom. ഇതിൽ some examples I can give. ഈ degree of freedom we have to write some additional points. Okay, monotonic and diatomic and triatomic molecules are there. For that the degree of freedom is different. Okay, so let's write that information also. Ippam some problem oxygen adhe madriyalla numericals varum. Numericals varumbode suppose if you want to calculate the degree of freedom, okay, degree of freedom inde value, so f is called degree of freedom. Degree of freedom chemistry use ചെയ്യുന്ന ഒരു term ആണ് degree of freedom. Okay, so ഈ ഒരു degree of freedom ത്തിന്റെ കോൺസെപ്റ്റ് തന്നെയാണ്. ഈ degree of freedom ത്തിന് ഇപ്പോൾ ഒരു mono atomic ഉണ്ട്. Similarly we have diatomic. Similarly we have polyatomic. ഇപ്പോൾ ഒരു ഡയറ്റോമിക്കിന് എക്സാമ്പിൾസ് ആണ് ഇപ്പോൾ O2. അപ്പോൾ ഇതുപോലെ ഇതൊരു മോണോട്ടോണിക് ഗ്യാസ് ആയിരുന്നാൽ ഡിഗ്രി ഓഫ് ഫ്രീഡത്തിൻ്റെ വാല്യൂ 3 ആണ്. ഡയറ്റോമിക് ആയിരുന്നാൽ ഡിഗ്രി ഓഫ് ഫ്രീഡത്തിൻ്റെ വാല്യൂ 5 ആണ്. പോളി അറ്റോമിക് ആയിരുന്നാൽ ഡിഗ്രി ഓഫ് ഫ്രീഡത്തിൻ്റെ വാല്യൂ 6 ആണ്. ഇത് physics it is required. I think substitute the gamma you have to find out in order to solve certain questions accordingly. Okay, so now we know he told it is an adiabatic process, so PV raised to gamma is constant. He told PV raised to gamma is constant. So what we'll do, we are going to find out the velocity of the sound wave based on these set of equations, correct? Okay, so let's go that. Okay, so now we know our equations. PV raised to gamma is constant. As like we have done previously, we are doing differentiations. So P into differentiation of V raised to gamma, gamma into V raised to gamma minus 1. Okay, P into gamma, so x raised to n, nx raised to n minus 1 into dV plus V raised to gamma into dP, correct? First factor into differentiation of the second is equal to second into differentiation of the first, constant differentiations are 0. We need to find out an expression for bulk modulus. What is the expression for bulk modulus? Minus dP. Okay, I told an expression for the bulk modulus. What is the expression for bulk modulus? dP divided by dV divided by V. This is the expression for the bulk modulus. So every formula we have to create from this one. So let me take this into the negative. So P raised to gamma, V raised to gamma minus 1 into dV is equal to minus V raised to gamma dP. But dP come. Then what we'll do? With a P dV has to take it downward. Okay, so let's do one thing. So P into everything gamma I'll take it here, P gamma, rest all terms I'm taking to left side. So V raised to gamma dP divided by then V raised to gamma minus 1 dV. Okay, so this can be written as V raised to gamma into dP divided by V raised to gamma into V raised to minus 1. But V raised to gamma minus 1 V raised to into dV. The V raised to gamma cancels. Okay, so this can be written as minus dP whole divided by dV into V minus 1 means dV divided by V in the value. So this is called what? Bulk modulus P. This is called the bulk modulus B. Now B is equal to what? It is P gamma. So now B is equal to P gamma. So now we can substitute in that equation so that we will find what will be the equations for the velocity. So I'll clear this area. Okay. So heading also let's remove it because we can save some space over here. Okay. So now the velocity equations. Now the velocity equation. Now the velocity equation. What is the velocity equations? Please tell me. Velocity is equal to root of bulk modulus by density. What is now our equation? What is our bulk modulus? It becomes gamma P. P gamma like gamma P divided by rho. Okay. Now we are going to calculate the velocity of the light. The velocity of the sound wave. So velocity of the sound wave means air 78% nitrogen aanullathu. Nitrogen. So nitrogen gamma value we are going to find out. So what is gamma is equal to 1 plus 2 by F degree of freedom. So 1 plus 2 divided by F. It's a diatomic. N2 is diatomic. So this is 0.4. So we will get 1.4 is the answer. Substitute will be there in this equation. So what are the values we are getting? V is equal to root of 1.4 1.05 into 10 power 5 divided by this air density 1.29. This simplify that you will get 332. You will get 332 meter per second. Okay, 332 meter per second. This is a value very closer to the practical experimentation value. Yes, 8 in the difference. That is not a big difference. That is the values most accurate value. This will become most very closer value. Because the nitrogen base calculated, the other elements will also be present. So the thing is like So according to Laplace correction is giving a corrections to Newton's law. Newton told it's an isothermal process and we got a value equal to 280 meter per second, and that is wrong. From there the Laplace correction equations are came, and it is told it's an adiabatic process. So the velocity of the sound wave will be equal to gamma p by rho. This equation is very important. This one, root of gamma p by rho. In many problems we will use this equation. So this is an important relation based on the Laplace correction. Okay, so we need to write some additional point also for this one. So let's continue. I will keep that equations will be there. Now we know the ideal gas equations from the chemistry also. PV is equal to nRT. Okay, so we'll use that equations and we'll calculate the things. So before that we will write some couple of points will be there. Okay, now let's write according to Laplace correction, velocity of sound in air is equal to 330 meter per second. That is very closer to the practical value. What is the practical value? That is very closer to the practical value, 340 meter per second. That is very closer to the practical value, 340 meter per second. Hence Laplace correction is accepted. Hence Laplace correction is accepted. Adine reject edilla, previously the wrong aayirunnu because of the Newton's law. Next we are going to write, we know PV is equal to nRT. This we know, we already know the ideal gas equations. What is N? N is the number of moles. How will calculate the number of moles? Given mass divided by molar mass. Correct? Given mass divided by molar mass. So then based on this one we'll get the number of moles, and R into T. Okay, so PV is equal to M divided by M. So now here I am going to do some manipulation. So this is an ideal gas equation. This already we know. Here P into M in multiply. PM is side load E RT I am keeping like this one. So mass per volume into RT. What is mass per volume? PM, capital M is the molar mass. So mass, small mass is a given mass. So this will become density into RT. So PM equal to rho RT in video. PM equal to rho RT. Now what we are going to do means P by rho. If P by rho, what you will get? P by rho equal to RT by M. This equation number 1, this equation number 2. This 2 equation number 1 in place RT by M in substitute. So what we will get? We got V is equal to root of gamma times of RT divided by M. This is also an alternate equation based on the gas theorem. It is created based on the ideal gas equations. PV is equal to nRT. So this is very important. This is important. This is important. Both are actually same, but one formula where gas equations substituted in terms of R and T. We have calculated the value of this one. Okay, what is the value of R? What is the value of R? In case if you are not remembering, R equal to 0.314. R will be equal to 0.314. Okay, so of course the unit is important, right? Joule per mole Kelvin is the unit of this one. So this value you have to remember. They are constants. So constants value you have to remember. What is called T? What is called T? T is called temperature. So please write that also. T is the temperature in Kelvin. How to convert into Kelvin? You have to add so temperature in Kelvin is equal to temperature in degrees Celsius plus 273. Degrees Celsius temperature 273 add. Of course you know. And capital M is called what? One more additional point. Capital M is the molar mass. Molar mass. This already definitely you know from the physical chemistry, this one, molar mass. Okay. So do not miss these values because these values are very much required to do so. Okay. This is not 0, this is 8.314 joule mole Kelvin. I wrongly written there. 8.314 temperature Kelvin ആണ് 90% questions temperature degree Celsius തരും adding with 273. M is the molar mass. Okay, which gas molecule will be given will be there. For example, in the question, if they specify like oxygen O2, so O2 ന്റെ molar mass ഒരു oxygen 16 ആണ്. ഇപ്പോൾ 2 oxygens വരുമ്പോൾ it is 32 gram ആണ്. അതിനെ കിലോഗ്രാമിലോട്ട് കൺവേർട്ട് ചെയ്യണം ഫിസിക്സിൽ പ്രോബ്ലംസ് ചെയ്യുമ്പോൾ. So that is very important. Okay, fine. So let's go to the next sessions over here. Okay, so now we learned about the two concepts. One is a sound wave based on the Newton's law, and that is a wrong postulates. Why? Because we got 280 meter per second from the Newton's law, and Laplace scientist will be given certain corruption. He told it's not an isothermal process because compression rarefactions will be there, so it's an adiabatic process, and based on the adiabatic we'll come up with the two equation gamma p by rho and gamma RT divided by m. So based on these two equations, now I know the Newton's equation is not correct, but Laplace equation will be correct. Now I am going to do certain analysis, how the temperature will affect, how the density will affect, how pressure will affect. So factors which are affecting on the speed or the velocity of the sound wave. That's the next topic. Okay, so let's move to that factors. What are the factors which are involving in this one? It is purely based on the equation only. There are no new concept or nothing new will be there. Okay, so let me clean this first and then we'll write the heading card. Laplace correction is very important, and there are a lot of questions are coming because that is a theory which is accepted over the Newtonian theory. Okay, so you can expect some questions from that area. So let's see. Okay, fine. So factors affecting on the speed of the sound waves. So factors affecting on the speed of the sound wave and speed of the sound wave. Factors affecting on the speed of the sound wave. Sound wave in the speed in a effect in the factors. What are the things will be there? So we know velocity. So first one is called temperature. How the temperature will be depends upon the speed or the velocity. So V is equal to proportional to root T. Okay, V is equal to gamma RT by M. I know, right? So first we'll write root of gamma RT divided by M. So velocity is proportional to root T. So I will write V1 is proportional to root T1. V2 is proportional to root T2. So I am dividing both LHS and RHS. I am dividing. So what will get? V1 divided by V2 equal to root of T1 divided by T2. So remember this equations. This will be applicable in all the places you can use this equation, and which is always valid. Okay, V is proportional to gamma RT by M. So V1 by V2 is equal to root of T1 divided by T2. Okay, next one, second factor is what? Gamma RT and gamma P by rho. So second factor is called pressure. We know the equations over here. V is equal to root of gamma P by rho. So this point, what is coming means when pressure increases. So let's say when pressure increases, if pressure increases ഒരു factor കൂടെ ഉണ്ട്. When pressure increases, density rho also increases. When pressure increases, density rho also increases. അതാണ് ഇപ്പോൾ ഒരു ടൈമിൽ pressure increase ചെയ്യുമ്പോൾ അവിടെ ഇരിക്കുന്ന ഡെൻസിറ്റി അതിൻ്റെ ഒരു കോൺസെൻട്രേഷൻ ആണല്ലോ ഡെൻസിറ്റി അപ്പോൾ ഡെൻസിറ്റി വിൽ ആൾസോ ഇൻക്രീസസ് സോ വി ഈസ് ഇൻഡിപെൻഡൻറ്റ് ഓഫ് ചേഞ്ച് ഓഫ് പ്രഷർ അപ്പോൾ പ്രഷറിൽ വരുന്ന ചേഞ്ചിന് ഇത് ഇൻഡിപെൻഡൻ്റ് ആണ് വി ഈസ് ഇൻഡിപെൻഡൻറ്റ് ഓഫ് ചേഞ്ച് ഓഫ് പ്രഷർ ഓക്കെ നെക്സ്റ്റ് പോയിന്റ് ഹ്യൂമിഡിറ്റി third point is humidity means you know the moisture content in the air okay density means more concentration on okay sometimes you may get some kind of a misleading in the sense of like density is weight. No, density is not weight. Density is the concentration. More number of peoples will be there, so concentration. So density of dry air, dry ആയിട്ട് നിൽക്കുന്ന density of dry air greater than density of moist air. Density of dry air greater than density of moisture. I know the density equation. Density will be coming reverse proportion. So V is proportional to 1 by rho എന്നാണ് ഇതിൻ്റെ proportionality. അപ്പോൾ dry airൻ്റെ density അധികം. So I can say velocity at dry air less than velocity at moist air. Velocity at dry air greater than velocity at moist air. Okay, so that is the things over will be here. So the factors, there are the three basic factors. Temperature effect change out, but pressure effect change out because pressure in proportional to density change out. Then humidity, that air lulla humidity in dry air lana humidity the density of the dry air is more than that of density of the the moist air. Okay, the value is 1.29. I don't know the exact values, but this value will be higher than this one. Okay, now hope you understood. And in the today's sessions we have discussed about the standing waves, sound waves, first node, second node, first harmonics, second harmonics, third harmonics over a string, then Newtonian equations we have learned. Then we learned about the Laplace corrections, and we have find out what are the factors which are affecting on this one. Okay, then well, stop it for today's sessions, and we'll continue with the next topic in the next sessions. So best of luck.